because. So there's a number in front of the x squared today. That's what makes these different from the ones that we factored in the past. This is your number one rule. Always check for a greatest common factor first. So I look at this. I've got 3, 21, and 36. Is there a number that goes into all of this? 3. So I could take a 3 out of all of those. And if I do that, I'm going to get 3 parentheses x squared plus 7x plus 12. And you can do that with the underlining thing. You'd make it 3 times 1 and 3 times 7 and 3 times 12. I'm just sort of fast forwarding. And so then with what's left, if I still have these 3 terms in the form that they were in the last lesson, x squared plus bx plus c, I can factor that further using our x method. So we're looking for numbers that multiply to make 12, that add to make 7. So what numbers multiply to, so 3 and 4. So you still keep the 3 in front of the parentheses, but you'll also have x plus 3 and x plus 4. So it's like there's an extra step. You're going to take out the greatest common factor out of all of the terms, and then you're going to factor what's left. That's the first kind of, so it's like combining the first 2 factoring lessons that we did in the foldy. Okay, so let's look at number 2. I don't have a number I can take out of all of them, but they all have y's. This one only has 1, so I'm going to take 1 y out of every term. So if I take a y out of the first term, I'm left with y squared. If I take a y out of the second term, I'm left with minus 5ay. And if I take a y out of the third term, I get plus 6a squared. Now we haven't factored anything that has 2 variables in it, but you're about to. For a moment, pretend that those a's aren't there. Pretend it's just y squared minus 5y plus 6. So pretend with me for a second, and let's factor that. So what multiplies to make 6 that adds to make negative 5?
5 and 1.
So negative 5 and negative 1. So you're close. So this would be y minus 5 and y minus 1. What's going to change is instead of just 5 and 1, we're going to throw in some a's. Yes?
What?
Okay, is it 5 times 1? 5?
You need to have your...
Oh, so you know what? That's not it. I think we want to use 3 and 2. Negative 3 and negative 2. You are correct. I was just going with it. I wasn't paying attention.
You're all sorts of out of it.
I am. So then what we're going to do is now they've added an a and an a squared in here. And we'll go ahead and add the a's in, and then I'll show you that it works. So instead of y minus 3, I'm going to have y minus 3a. Instead of y minus 2, I'm going to have y minus 2a. And then if I foiled that out, I'd get y squared minus 2ay minus 3ay, which would give you the minus 5ay. Minus 5ay right here. And then negative 3a times negative 2a is positive 6a squared. So it's just adding in some extra letters. You're not going to see a lot of those, but just thought I'd throw that in there. And so if you look, it goes y squared and then y and then nothing. If you go backwards, it goes a squared and a and then nothing. That's when you know that that pattern's going to work. Okay, let's do a couple more just normal ones. So on number 3, we can take a 5 out of everything. So if I divide this by 5, sort of, we're just factoring, not really dividing, I'd be left with x squared plus, what do you take times 5 to get 30x? 6x. And then what do you take times 5 to get 45? 9. And so this has the 3 terms like we were seeing yesterday. It's a quadratic trinomial with a leading coefficient of 1, just like we talked about before. So we're looking for numbers that multiply to make 9, that add to make 6. So 3 and 3. So I'm going to have 5 and x plus 3, x plus 3. And when you get 2 of them, it's customary just to write it x plus 3 squared. Like you could even skip that step and just do this because it is shorter and faster. And this is a skill that you're going to use to do other things later. All right, so let's take a look at number 4. Can I take a number out of all of those numbers?
I don't know.
3 and 24 and 48. 48 is just 24 times 2.
Well, I know 3 can go to 24, but can it go to 48?
Well, since 48 is 24 times 2,
Then yes.
then yes.
Then yes.
So we're going to take a 3 out of everything. So it'd be x squared minus 8x, and since this is twice as big, that'll be twice as big as 8, which is 16.
If divisible by 3 is you add the digits together, and if that number is divisible by 3, then it is.
That's true. There is a trick. So if I add 4 and 8 together, I get 12, and that's a trick. Since 12 is divisible by 3, then 48 is divisible by 3. I remember talking about that in middle school. Yay. Okay, so you probably learned it somewhere else first, but all right. So we're going to factor the x squared minus 8x plus 16. So you have 16 up here, negative 8 down there. So it multiplies to make 16, and it adds to make negative 8. So that'd be negative 4 and negative 4. So this would be 3. It's still out there, x minus 4 and x minus 4, or you can just write it as x minus 4 squared. So I threw in a couple that are going to have that squared in there. These that have that part that we just did from here to here, it's called a perfect square trinomial, which we'll talk about a little bit more later, but they show up. Okay, so those are the examples where you have a greatest common factor that you can take out of every term to make it easier. You should always check for that first. You might want to highlight that up here at the top, or put a little bubble around it.
I use my nail polish highlighter.
Yes.
There it is.
Okay, so I kind of put a little cloud around mine, but that is always what you want to do first if there's a number in front of that x squared term. Now on the bottom half of the foldy, we start to look at what if you can't do that. So there's a 3-step process. It's actually more like 5 steps, but this is the part that, so it's called slide, divide, bottoms up. It sounds like a dance, but it isn't. Slide, 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 slide. Okay, I don't know. We're going to move on.
How would you bottoms up?
Okay, bottoms up.
You divide. And then your bottoms are up.
Okay, yeah. Okay, so let's go through this. So if I look at number 1, there's a 7, a 29, and a 4. There are no common factors there. 7 and 29 are prime. So your first step is to slide. We're going to take this 7 that's kind of making all the problems. We're going to slide it, if I can quit breaking my lead, down here and multiply it by the 4 on the end. So we rewrite it with the 7 down there. So I have x squared plus 29x plus, and I go ahead and do the 4 times 7 and make it 28. We kind of sort of changed the whole value of everything, but it's okay. This is just a trick. So then we're going to make our x and factor like you normally would. So I would have 28 on top and 29. So it multiplies together to make 28 and adds to make 29. 28 and 1. So that's pretty easy. X plus 28 and x plus 1. Now it's not exactly legal in mathematical terms to take the 7 and multiply it over here. And that's where the 28 and the 1 came from. So we're going to fix it. Since we multiplied by 7, we're going to take both of these numbers now and divide them by 7. And so you divide and you reduce all fractions that reduce. So 28 over 7 we can reduce because 28 divided by 7 is 4. And then with anything that doesn't reduce further, that's where the bottoms up comes from. The 7 jumps up in front of the x, and you get 7x plus 1. This is a cool trick that I learned from a video from some guy in Australia, and it works. If you multiply these out using your FOIL method, you will get 7x squared plus 29x plus 4.
That's freaky.
The only other way that I know of to do this is to guess and check different numbers in the parentheses until it works, which takes a really long time. That's the way a lot of textbooks that I have used taught it. But this is a little trick that works, and it's really cool. Okay, and we can use stuff that we've already learned. So let's go ahead and go over to number 2. Okay, so on number 2, I look, there's a 2, a 3, and a 9. I can't take anything out of that. That's when I know to use this method. So the 2 is going to slide down here and multiply by the 9. So I will have x squared minus 3x minus 18. So that was the slide part. So we were sliding the 2. Okay? Then what you're actually going to do next that's not in those steps is you're going to factor. So that's where the x comes in. We're looking for numbers that multiply to make negative 18, that add to make negative 3. So I'm thinking 6 and 3. So negative 6 and positive 3 will add to make negative 3. They multiply to make negative 18. So you make your two sets of parentheses. Since x is our variable, we put x in there. And you'll put minus 6 for the negative 6 and plus 3 for the positive 3. Now, like I said, it's not exactly mathematically correct to just take this number and move it and start multiplying. So now we have to fix it. So since we multiplied this number by 2, and that's where both of these numbers came from, we're going to divide both of them by 2. And then reduce any fractions that reduce. So 6 over 2 reduces. We get x minus 3. 3 halves does not reduce. We don't want a mixed number or anything like that. So if it doesn't get any smaller by just dividing them by something, then we just bottoms up the 2, and it goes in front of the x. 2x plus 3. So we did the slide. This part was the divide. And then we did the bottoms up. Okay, so we're going to do a couple more. Hello. So we're working on our full day. We're almost done. Let's go down to number 3.
But there is a greatest common factor in this one.
There is a greatest common factor, so we're going to take that out first.
That's why I was so confused.
Yes.
Can you go back to the other one for just a second?
Yes, I'll go back to number 2 for just a second.
No.
And I meant to write that up there further when we'd have room, but that's okay.
Damn.
All right, got it?
Like, hey. Oh yeah, she's recording.
Okay.
So, this was on the floor.
All right, so on number 3, there is a common factor. I can take 2 out of everything. So I can make this 2 times 2x squared plus 11x plus 5. So it's like dividing everything by 2 and we stick the 2 out in front. That's what factoring the greatest common factor looks like. But I didn't get rid of the number in front of the x squared. There's still a number there. So that means I'm still going to slide, divide, and bottoms up. All right? So, we're going to take the 2, slide it down here, and multiply it by the 5. So I have to remember that there's still this other 2 we took out in front of everything, okay? So I took this 2, divide it, so I have x squared plus 11x plus 10, and now it's like in parentheses because I had to take out that 2. It's sitting over there. Make my x. We're looking for things that multiply to make 10, that add to make 11.
It's 1 and 10.
So 1 and 10. So we factor that, x plus 1 and x plus 10. And we slid this 2 and multiplied it down here, so now I have to go through and divide both of those numbers by 2. So this one's going to become x plus 5, and that stays. This one, the 1/2 can't go any further, so we bottoms up, put the 2 in front of the x, 2x plus 1, and then we still have the 2 that we factored out with the greatest common factor in the beginning. So always take out the greatest common factor first, and then proceed as usual. Was I off the screen that whole time?
Yeah, that's why I was confused.
I'm sorry.
It's okay.
There you go. I
It was
will.
like kind of on it, but it was like on the whiteboard. So.
Okay, yeah, my projector's a little crooked.
This
All
is
right.
the worst thing to ever happen to me.
All right, so we're going to do number 4, which is the same kind of deal. I will try not to be off the screen for that. All right, so number 4. We got 4, 38, and 70. Can we take anything out of all of those?
2.
2. So I'm going to do that over here. So we're going to take out a 2. And so think of it as like dividing by 2. 4 divided by 2 is 2. 38 divided by 2 is 19. And 70 divided by 2 is 35. Okay, so that 2 is just going to sit out there no matter what. I'm going to put my x over here to save room. So we're going to multiply to get 35 and add to get 19. So let me think. What goes into 35? So
Wait, should we slide first?
oh yeah, you're right. I did forget to do that.
Okay.
I'm not going to want to use this video. So we got to slide the 2 down here. I'm like, why isn't this working? And so take 35 times 2. So it's going to be 2x squared plus 19x plus 70. So we're actually going to have 70 and 19, and that will work a little bit better. So 70 and 19. So 70, if we think about what makes 70, I've got 1 and 70, 2 and 35, 5 goes into it,
5 and 12, yeah, that's right.
5 and 12, no, 5 and 12 is 60, so it'd be 5 and 14, that adds up to 19. There we go, 5 and 14. So, and I forgot that I took that 2 off right there, and that's only x squared. All right, so we've got 2, and then we'd factor this x plus 5 and x plus 14. And since we slid the 2 up here, we're going to divide both of these numbers by 2. So 14 divided by 2, we can go ahead and make x plus 7. Then we've got a bottoms up, this 2, which makes it 2x plus 5. And we've got a 2 out in front that we factored out in the beginning.